Hello and welcome again. My name is Matty D and this is Networks Equals Yes, a place where every network task is achievable. For this video, we're going to go full layer 3 by discussing static routing. We will also be discussing public versus private IP addressing and subnet classes, which are all important things in the layer 3 world. Now, before jumping into today's video, I'd like to quickly talk about my Patreon channel. It now contains config transcripts from all my videos for members. So feel free to become a monthly subscriber if you'd like to support the channel and have access to configs from this video on top of being recognized as a Patreon subscriber in future videos. Alright, let's go ahead and dive right in and let the network adventure begin. In this lesson, we will be using IPv4 addressing, and more specifically, we'll be using the two types of IPv4 addressing, which is public and private IP addressing. Now, when it comes to public IP addresses, the important thing to know for this lesson is that public IPs are used in a WAN infrastructure, such as the World Wide Web, and these addresses are routable across the internet. An example would be the 8.8.8.8 address used by Google.com. Now, when it comes to private IP addressing, it is important to know that these networks are restricted to LANs and are not routable over the internet. So let's go ahead and break these down a bit more and talk about reserved versus public IP addresses. Okay, so before we break down public versus private, I want to talk about IP classes. More specifically, I want to talk about IP class A, class B, and class C, and how IPs fall under these classes. Now, you may be asking yourself at this point, what are IP classes? Well, a simple way to break it down is to think of each class as a representation of an IP scope capacity, with class A being the biggest scope of IP addresses and class C being the smallest scope. And the best way to break this down is to do this with private networking. So let's go ahead and do that. So just like public IP addressing, private IP addressing falls under classes. However, the difference is that private IP addressing only allows for certain subnet ranges. And those are as follows. For a class A, you're given 10.0.0.0 all the way to 10.255.255.255. And then for class B, you're given 172.16.0.0 to 172.31.255 and 255. And lastly, you have your class C, which is 192.168.0.0 to 192.168.255.255. And if you haven't figured it out yet, the difference is for the class A, the last three octets can be fully configured. For the class B, the last three octets can be somewhat configured, but it's not completely able to be configured. And for class C, only the last two octets can be configured. And what that has to do with is the number of IP addresses available in each class. Now we're going to go ahead and stick with class C for this lesson because it'll be the easiest to break down. And again, a class C means we only use the last two octets of an IP address. So for the IP subnet of 192.168.0.0, only the two zeros on the end will ever change. And each number change in the third octet equals 254 usable IP addresses in the fourth octet. Now, I'm not going to make an entire lesson of subnetting because we'll be here all day, but basically the private class C will always start with 192.168 because this address was identified years ago as the private class C address. However, this is not to say the other private addresses of 10.0.0.0 and 172.16.0.0 can't also be class C private addresses because they're able to rotate all three of their octets. So a 10.0.0.0 can be a class A or a Class B, or a Class C when used in a private network because it has the IP space to do so. Sounds confusing, right? Well, let's go ahead and list a few IPs to hopefully break it down a bit more for you. So the IP address currently displayed is a Class C address of 192.168.1.0. And you can see here that there is 254 usable IP addresses for this Class C subnet. And if I raise the third octet by just one, I would create a new subnet with another 254 usable IP addresses. Now you may be asking at this point, what if I want more than 254 usable IP addresses for a single network I have built? And the answer is, you would simply go from a 255.255.255.0 or a /24 subnet to a 255.255.254.0 or /23 subnet, which would give you 510 usable IP addresses. And if you want more than this for usable IP addresses, you could then change your IP address to a Class B in the 172.16 range or a Class A in the 10.0.0.0.0 range, which would then give you 16 million usable IP addresses at the highest for and this would all be within your private network. Now, this would most likely be overkill for any private network you build, but it is important to know you have the option to do so if you wanted to within a private LAN. Now, the important thing to remember with all these IP addresses in a private network is that they are private and contained within a LAN. You can never use these addresses out on the internet. They are specifically reserved for LAN networking. So, let's go ahead and move on now and talk about strictly public IP addressing. Now previously I showed you the ranges of private IP addressing, and the thing to know when it comes to public IP addresses is that anything not in those private address ranges is considered to be a public IP address, which means they can be routed across the internet. This also means that there's a whole lot of them, and that's because public IPv4 is the backbone of the World Wide Web. So here's a few things to know about public IP addresses. The first thing to know is that public IPs can be used in a private network, but cannot touch a WAN network unless the public IP is owned or leased by the proper authority, and that is because it would cause an IP conflict, and it most likely wouldn't work. So you can use a public IP in a private network, but it has to be contained within that LAN. It can't touch the WAN. Second thing is that most public companies own or lease a small slice of public IP addresses, which are typically in the Class C or B range because they don't usually need that many IP addresses to make their companies operate across the internet. And the last thing to know is that pretty much every home router connected to the internet and connected to an ISP to surf the internet is using at least one public IP address. Now you may be saying, but I have several devices at my house that connect to the internet. Are you telling me each of these use a public IP? And the answer is most likely not. And that is because routers use natting to translate a private IP address into a public one. But that's for an entirely different lesson. But I will be using natting in my network topology to show how a computer at home can access the web. Okay, great. Now that we've discussed private versus public networking, let's go ahead and talk about the static routing topologies. Now, the ones I'm displaying here above are basically showing public routing as a series of routers connected together. And the private to public is an inline routing situation, meaning that the computer is going on a straight line all the way out to the WAN, which is common for this type of networking. So let's first talk about the public topology. Like in the real world, public routing is a collection of routers all sending traffic to one another using public IP addresses. They can do this either statically or dynamically, with the latter option being the most likely option used. Now, when it comes to private IP addressing, typically you will see an inside network pointing to a gateway address that is on the outside going out to the WAN, which is what is displayed above. The difference between these two network types is the public routing tables will have a routing table statically populated with the gateways to reach all the routers in the most efficient manner, whereas in the private network you will see a single route configured telling all traffic to go this way to get out. The other difference is that the top network portion will only contain public IP addresses, whereas the bottom will contain a mix of private and public IP addresses. This is because the top routers reside only in a public network and the bottom is in a private network device or contains a private network device looking to get out to the public network. Okay, so let's go ahead and talk about the network addresses used in these two topologies. You can see in the top topology I am using 3 different public IP subnets, whereas in the bottom private/public network I am using 1 private network and 1 public network. Now, the overall goal for this lesson is to create a static routing table that allows for all our routers in the top public topology to be able to reach one another. More specifically, I want to make sure that all public networks can hit all other public networks using the shortest possible path to get there, which is where our static routes are going to come in. And for the goal of our private/public network topology, which is the topology on the bottom, it's just to make sure that our standalone computer can reach all public routers in the above WAN topology. And this will be done by configuring a single default route out. Now, this probably all seems a bit confusing, but don't worry, we're going to be covering all the routing involved in this lesson right now. So, in this lesson, you're going to see 2 types of routing tables with 2 types of static routes. The first type of static route you will see within a routing table will be on the WAN side of things, the public networking. And it will contain several route statements that tell the occupying router how to get to the other routers within the WAN. Now, in the example above, you are seeing the route statements configured within the router, and it is important for you to know what it is you're actually looking at going forward. So, in the top statement, we see that it says the word IP route followed by 4.4.4.0 and then 255.255.255.252 and lastly 3.3.3.2. So the first part where it says IP route is just specifying that this is a static route set in the router. And the second portion where it states 4.4.4.0 and 255, 255, 255.252 is telling us the network we are seeking and the size of it via subnet, which in this case would be a small /30 network that's going to be containing 2 usable IP addresses. And finally, the last part is showing us the pathway or gateway our router should take to get to the desired distant route. So, in layman's terms, the end part is saying, hey, I see you are directly connected to a router with the IP address of 3.3.3.2. So if you're looking to get to the 4.4.4.0 network, the gateway to get there lies in this direction. The next type of static route we will be seeing in our routing table will be in the public/private mixed network. So this statement looks similar to the last statements, except you'll see that in the middle portion, it doesn't specify an exact IP address, but instead just has a collection of zeros. Well, the reason for these zeros is that they are indicating all IP addresses using any subnets, meaning that the zeros are specifying that any IP address and any subnet can be reached going this direction. So This default route is simply telling any device looking to get out to the WAN that all IP addresses period within that WAN are in the direction or can be found in the direction of the 6.6.6.1 address. And this works because all our internal traffic can only go one direction to get to the WAN. Now, you may be asking yourself why I don't just put these default routes on all my devices and be done with it, meaning the public and the private. Well, the big reason is that it's not an efficient way of routing, because on the WAN network, we want to specify the best pathway to get to another router. And if I just specify a default route, then the router will just send traffic out any way it can. And it may take the IPs longer to get from one router to another, compared to me saying, take this specific route to go here because it's shorter. Make sense? Great. All right, well, let's go ahead now and start this network adventure by snapping our fingers and bringing ourselves to the topology page, which here we are. Okay, so I'm going to go ahead and start by talking about the public side, the public network, which is represented in this green box. All right, and then you can also see that our home router is actually in the blue box, which is our private network, and the green box, which is the public. All right, so let's first talk about one of these routers. So let's talk about WAN 1, and let's look at the interfaces within that router. So you'll see that I have Ethernet 00, which is configured with 2.2.2.1, and Ethernet 0/1, which is configured with 3.3.3.1. All right, so I'm going to be building a routing table on here. I have the interfaces already configured, but I'm also going to be configuring this routing table that I'm statically assigning to say that I want to get to specific addresses, in this case the 4.4.4.0 and the 6.6.6.0 address subnets in the what I believe to be fastest path to get there. So in this case, I'm saying to get to the 4.4.4.0 subnet down below here, this little /30, I'm saying take the 3.3.3.2 default gateway, which is going to be the IP address on the interface Ethernet 0/0 over here on WAN 3. All right, and then I'm also saying to get to the 6.6.6.0 subnet, which is the network configured on the interface of the home router here and on WAN 2, I'm saying go ahead and take 2.2.2, which is going to again going to be the Ethernet 00 on my WAN 2 router, right? So I'm saying take this left here to get to the home router here, and I'm saying take the right here to WAN 3 to get to the 4.4.4.0/30 network. All right, and then like I said, each one of these routers is going to be having route statements configured in them, just like I just told you in the WAN 1 router. So let's go ahead now and talk about the private/public network over here in the blue square. Now you can see that my home computer is configured with an address of 192.168.1.10, and that's in a /24 private network. Like I said earlier in the lesson, the 192.168 is a private IP address. And that is then connected to my home router, which also has that private address configured on its Ethernet 01 address, but it also has a public IP address of 6.6.6.2 configured on its outside interface, which is again the public facing side. And then on this router, I will also have this default route here, which, like I said in the previous lesson, is specifying any IP address out here in the public can be discovered using the 6.6.6.1 address, which sits on Ethernet 02 on my WAN 2 router. All right, so let's go ahead and start configuring. I'm going to start this adventure and end it both on the home computer to show you that we're not routing to begin with, but we will be once we put the routes in all these devices. All right, so let's go ahead and start. Okay, so here we are in the home computer, right? This is the lone computer sitting in my private network. And you can see here that I have a private IP address of 192.168.1.10, and my gateway is the home router of 1.1. And what I want to do is be able to get out to the internet. So let's go ahead and pick a random IP address. Let's say the 3.network or the 3.3.3.network, right? So I'm going to say ping 3.3.3.1. All right, now you're going to see here that my address is trying to send a packet out, but then I'm getting an error simply saying that the destination host is unreachable. And that's because there is no routing currently set on my home router or the public routers for them to be able to find each other. All right, so let's go ahead and now move on to my home router to do the routing, static routing there, and then I'm going to do it in the public routing, and then we're going to come back to this computer and try it again. Okay, so I'm on my home router, right? And as I said in the topology earlier, I want to configure a default route out here. Now, I already have my interfaces configured. And you can see that my Ethernet 00 is configured with a 6.6.2, 6.6.6.2, and my Ethernet 01 going back to my computer on the inside is 192.168.1.1, and they're both up. All right, so now what I want to do is I want to say that all traffic coming to this router should take the direction to go to the router in WAN 2 at the interface, gateway interface, or gateway address of 6.6.6.1. All right, so let's go ahead and do that. All right, so I'm going to again put in IP route like you saw in the lesson, okay? And then I'm going to say 0.0.0, meaning all IP addresses in that direction. And then I'm going to say 0.0.0, meaning in any subnet size when I go that direction. So all IPs in any subnet. And then I'm going to specify my next hop, which is going to be the interface on my WAN 2 router, right? That's connected to this router, which will be 6.6.6.1. All right, and there it is. So I'm going to go ahead and commit this. Or not commit, that's a Junos. I'm going to copy run start this. Do copy run start. Alright, and the first thing that I'm going to do is make sure that I can ping that directly connected router. So let's do ping 6.6.6.1. And there it is. You can see that I can clearly ping across with all 5 of my pings, right? I think that's 5, yeah. Alright, so the next thing we want to do is set up a quick little NAT for our private IP address to be able to route out to the WAN. Alright, and what that's doing is it's essentially hiding our private inside IP address with the public IP address assigned on this router so that it can get out to the WAN. Because again, public IPs can't reach private IP addresses or vice versa. So let's do that. I'm just simply going to say interface Ethernet 01 where my private is, and I'm going to say IP NAT inside. Now I'm not going to go in great detail about this because I'll do NATing in another lesson, but I'm just going to quickly do this so that you can see that it works. All right, and then I'm going to go to interface Ethernet 00 and say IP NAT outside, and then I'm going to simply say in my config IP NAT inside source, and then you see here static, and then it's going to say inside local IP address, and that's going to be my 192.168.1.10. And then I'm sorry, I also got to put in the outside, which is going to be my 6.6.6.2. Alright, and there it is. And then we're just going to save that one more time. Alright, now let's go ahead and move out to our public and do all the routing there. Okay, so now we're in our first public router, which is WAN 1. Alright, and as I said before, I already previously configured the interfaces on this router. So you can see that 00 is 2.2.2.1 and 01 is 3.3.3.1, both public IP addresses. And if you also remember from before, we said that the two networks that we need to get to from WAN 1 would be the 4.4.4.0/30 network and the 6.6.6.0/30 network. So we identified before by looking at our topology that the fastest way to get to the 4.4.4.0/30 network was to take the route through the 3.3.3.0/network. So let's go ahead and do that now. So let's go ahead and sit there and say IP route. All right, and then we're going to say we want to get to the 4.4.4.0, and it's a /30, which is a 255.255.255.252. And the way we want to get there is to take the interface on the connected router, which is 3.3.3.2. Okay, and then to get to the 6.6.6 network, we're going to take the opposite direction. So again, we're going to type in IP route 6.6.6.0, and again it's a /30. And this time we're going to take the other router, the other direction, all right, which is 2.2.2. All right, so then we can sit there and say copy, run, start. Oh, do copy. I've been forgetting that. Do a lot. Copy, run, start. All right, so let's go ahead and test this out. So let's see if we can first get to the 6 network, because we know that's configured. The other one hasn't configured yet, so we won't try it, but we'll try the 6. I'm simply going to say do ping 6.6.6.1. All right, let's see if we can get to the home router. There you go. All right, so we know that route's good. And once I configure the other public routers, it should be good all the way around. So let's now move on to WAN 2. Okay, so now we are in the WAN 2 router, and you can see above I once again forgot to put the do command in, but I got it eventually. All right, so if we look at our interfaces, we have 3 configured on this one because one is connected to the home router on top of the other 2 public routers. So our addresses are 2.2.2, 4.4.4.1, and 6.6.6.1. And the 6.6.6 is the home router, the 4.4.4 is the WAN 3, and the 2.2.2 is the WAN 1. Alright, so in this case, we want to be able to get to the 3.3.3 network. And the fastest way that we identified to get there, in this case, would be go through the 4.4.4 network, right? So here's what we're going to do. I'm going to type in IP route. All right, and we want to get to the 3.3.3 network, which is a /30. All right, and the way we want to get there is we want to go 4.4.4.2, which is the WAN 3 connected router. All right, and so we're going to go ahead and say yes to that. And that's the only route that we actually have to put in here because we're directly connected to the 6.6.6. So we don't need a route for that. So that would be the WAN 2 router. So let's go ahead and now move to WAN 3. Okay, and this brings us to the WAN 3 router. And you can see my interfaces here are 3.3.3.2, which is my connection to the WAN 1 router, and 4.4.4.2, which is my connection to the WAN 2 router. Now the network I want to get to on this one is the 2.2.2 /0 or .0/30 network, which is the connection between the WAN 2 and WAN 1 routers, and the 6.6.6.0/30 network, which goes to my home router. So let's go ahead and put the routes in here as well. IP route, we'll say 2.2.0, 255.255.255.252 because it's /30, and the hop we're going to take is we're going to go through our WAN 1. So we're simply going to say 3.3.3.1. Alright, and then we also need to get to the home router, which is going to go the opposite direction. So we're going to say IP route 6.6.6.0, 255, 255, 255, 252, because again it's a /30. And this time we're going to go through the 4.4.4.1, which is the IP address set on the WAN 2 interface connected to WAN 3 router. And there it is. Alright, so at this point, we've essentially, let's go ahead and save it actually, but we've essentially configured all of our public routers and our private. So let's do this. Let's make sure that this WAN can reach every IP address in the public. So let's start with the one that we just configured, 2.2.1. Yes. Yes. All right, and let's try 3. Now this is directly connected, so it should definitely connect. Yep. Now let's try 4. 4.4.4.1. All right, so we now know from WAN 3 that we can get to every single router in the public WAN network. All right, this is our internet and everything's connected. I'm going to go ahead and assume that the rest of the routers are already configured correctly the same way and that they can all reach each other now. So let's jump back to our home PC to see if it now can get out to the internet routers. Okay, and now at the end we're back to our home PC, and we're going to make sure that we can now get out to the internet. So our internet addresses are 2.2.2.0/30, 3.3.3, or 3.3.3.0/30, and 4.4.4.0/30. All right, those are all our internet addresses, So this is a private. I put the NAT in on our home router so that our private has the gateway to hide behind the 6.6.6.0/30 network, and the route is set for all traffic privately to go to the 6.6.6.1 address on the WAN 2 router. So if everything is configured correctly, I should be able to reach every router in the public network from my home PC. All right, so let's try that. So again, you can see my IP address here on this home PC is 192.168.1.1.10. All right, so let's try this. Ping. Let's try the WAN 2.2.1. And there it is. I'm pinging just fine, which tells me my NAT is working good, and it tells me the default route that I set on the home router is also configured correctly. All right, so let's go ahead and try it now with the WAN 3. Again, I can ping out no problem. And again with WAN 1. Actually, I already pinged WAN 1, so we'll ping WAN 2. We'll just do the other number, 4.4.4.1. There you go. And there it is. So let's go ahead and click back to our topology here real quick. All right, and so you can see that from this home computer, I can reach out not only to my home router, but all the way out to all these routers in the WAN, meaning that my entire private to public and public to private network is operational, and that all the static routes that I put in here are working as they should. And that, ladies and gentlemen, is the video. Thank you for joining me, and I hope you can join me again for our next lesson where we go on another network adventure. Have a wonderful day.